In this video, we are going to start our work with solving exponential equations. Exponential equations are equations in which the variable is in the exponent. So this first equation here, 5 to the 2x minus 1 equals 125, is an example of an exponential equation. The first strategy for solving exponential equations is to try to rewrite the equation to a common base. Both sides of this equation to the same base if possible. In this video, we are going to look at 3 examples where we can change the two sides of the equations to the same base. This is the easier exponential equation to solve because once the bases are the same, we're going to just look at the exponents and ignore the bases. In the next video, when our bases are not easily rewritten to the same base, then we're going to use the logarithm. Okay, so you look for that in the next video. But as you look at these two sides here, we know that 125 is a power of 5. So we can rewrite this right-hand side as 5 to the third power, and that's the first thing we're going to do. Okay, so we've achieved our goal now. Both sides of the equation have the common base. And once you have the same base on both sides, then you can ignore the bases. We're going to work with just the exponents. And the reason that we're allowed to ignore these two bases here and work with just the exponents is because of that one-to-one relationship that exponential functions have. We studied that in a previous video. So I'm literally going to rewrite just the exponents and make a new equation just like that. And now we're just going to solve for x. This is a linear equation, so you know that you're going to add 1 to both sides and divide by 2. Now these are easy to check, right? So let's check that while we're here. So 5 to the 2 times 2 minus 1, and we're going to check to see if we get 125. And here we get 5 to the 4 minus 1, which is 5 cubed. And that checks because that is 125. So the solution to problem number 1 is x equals to 2. Let's try another example. Okay, problem number 2, we have 4 to the 2x equals 1/2. So can we rewrite these two sides to the same base? And I'm sure that you know that the base is 2. So we can definitely rewrite these using base of 2. So we're going to rewrite both sides of this exponential equation with the same base. So 4 is 2 squared. So we're going to replace this 4 here, this base of 4, as 2 to the power of 2. So 2 squared, there's my 4, right? And that's being raised to the 2x. So I'm just rewriting that. And then over here, 1/2 is 2 to the negative 1. You know that that negative 1 exponent means reciprocal, right? And 1/2 is the reciprocal of 2. So now here on the left-hand side, we can use our power rule here to multiply these two exponents, right? Power rule of exponents, which we've studied before. So I'm going to write 2 to the 4x equals 2 to the negative 1. And now, again, we have these same common bases on both sides, so we can ignore the bases and work with just the exponents. So we're going to rewrite 4x minus 1. And now divide by 4, and x equals to the negative 1/4. Okay, let's check this one. So I'm going to write 4 to 2 times negative 1/4, right? And then we're going to check and see if we get that 1/2. That's a question mark. Okay, so 2 over 1 here. So we get 4 to the negative 1/2. Do you remember what a negative 1/2 exponent means? The negative means reciprocal of the base. So we could write 1/4 to the 1/2. And then the 1/2 means square root. So what's the square root of a fourth? Square root of a fourth is 1/2. Now, if you can't see that as clearly, or if you've forgotten some of your rational exponents, then just use your calculator here, right? I'm going to use 4 to the, and it was negative 1/2, right? So negative 1/2, and then hit enter, and there's my 1/2. Let's do one more example. And now we've got 3 to the 7x equals 81 to the 4 minus 2x. So this is starting to look a little bit more complicated. But again, can we rewrite this exponential equation with the same base? And 81 is a power of 3, right? 81, you know, is 3 to the 4th. So we're going to replace the 81 here by 3 to the 4th. So let's leave the left-hand side the way it is. And then here we have 3 to the 4th, and then to the 4 minus 2x. Just like that, right? We can multiply exponents, so we've got that power rule happening here. Now be careful here, because I better put this in a parentheses. That would be better. Because when I multiply with this 4 here, I'm going to want to distribute. Matter of fact, notice how we have the two bases are the 3's. So let's just work with the exponents. So I'm going to write 7x equals 4 times 4 minus 2x. And now I'm going to distribute over here. And again, so now we're just using our algebra skills, right? Okay, so there we go. And then we want to get these two x's together. So we'll add 8x to both sides. And so that's going to be 15x equals 16. And then we'll divide by 15. So x equals 16/15. Now, checking this guy, let's use that calculator, right? Because there's quite a bit of fraction work going on here. When I come over here to my calculator, I'm actually going to take my answer and use the storage key, and I'm going to stow that into the variable x. That way I don't have to keep typing 16/15. So I write 16 divided by 15. I'm typing that in, and then I'm going to use that stow key right here. Right? It puts that little arrow, and then that's going to go into x. And then when you hit enter, okay, and it gives you kind of the decimal approximation, right, of 16/15. Okay, but now you've got that answer stored in x, and what we want to check is what's 3 to the 7x, right? So let's do that. So 3 to the 7 times x. Okay, and I get this answer, right? And now I'm going to do the other side of the equation, which was 81 to the 4 minus 2x. And we'll see if these match. So, okay, so I need 81, 4 minus 2 times x. Enter. Okay, so now notice how my two numbers match, which means we got the right answer, right? So 16/15 is x. I hope this helps. Now, go on to the next video. In the next video, we're going to tackle something like this, where notice how we cannot rewrite these into a common base. So now we're going to have to use logarithms. That'll be the next video.